Right, so this lesson is called Circles and Lines. So what we're going to do first is we are going to take a look at some terminology associated with some special lines that have to do with circles. These are the terms radius, diameter, chord, and tangent. And then we're going to use the formulas that we've been working on in this unit for length, midpoint, and slope, and use them to solve problems involving circles and these lines that are associated with them. Okay, so what we've done kind of so far in this unit is we've learned, again, these formulas that we've been working with, and we have learned some basic properties of circles. We're going to start shifting into the next thing that we want to do in this section of the course, which is showing things are true or finding out if things are true or proving something to do with a certain geometric situation. But we'll start with these circles. So there are a number of special lines that are associated with circles. So our first one is what we call a radius, which is just a line drawn from the center of the circle to the edge of the circle. And we've talked about this previously. That radius distance is the same for any point on the circle. If we have a line that passes from the edge to the edge and goes through the center, we call this a diameter of the circle. And of course, a diameter is twice as long as our radius. If we have a line that goes from one edge to the other edge and does not pass through the center, we call this a chord of our circle. And finally, if we have a line that is outside of our circle, that comes along and touches our circle at one point, but does not pass through the circle, we call this a tangent to the circle. And the other thing to note about tangents is a tangent line, this red line that we see here, is going to be perpendicular to a line from that point where it touches the circle to the center. So it is perpendicular to, and that line could be either a diameter or a radius. So with these definitions out of the way, let's take a look at some of the problems you might be asked involving these lines and circles. So here's our first one here. We are told that a line segment has endpoints A and B. A is at 8, 6, and B is at 6, -8. They want us to show that AB is a chord of the circle. X squared plus y squared equals 100. So to answer this question, we have to consider what it means for something to be a chord. Well, a chord has to connect 2 points that are on the circle. So points A and B have to be on the circle. And for it to be a chord and not a diameter, it has to not pass through the center. Not pass, let's say, through the center, i.e. it is not a diameter. So when they ask us to show that this is a chord, they're asking us to show these two things. We have to show that A and B are on the circle, and then we have to show that this line AB is not a diameter. So let's start by showing A and B are on our circle. We can do this with a simple left side, right side check. If point A is on our circle, it has to satisfy the equation of the circle. So for point A, let's do a left side, right side check. Our left side is going to be x squared plus y squared. Our right side, of course, is 100. So we sub in our x and our y from point A. So that is going to be 8 squared plus 6 squared. And we work it out. 64 plus 36 is 100. All right, so left side matches right side. We have shown that point A is on our circle. All right, let's do the same thing for point B. Our left side here is going to be, well, our right side is easier. It's 100. Our left side is going to be, let's sub in 6 for our x, so 6 squared plus -8 squared. And if we work this out, we get 36 plus 64 equals 100. Okay, so therefore, A and B are on our circle. And so that's the first thing proven that we needed to show. Now, how can we show that this line AB is not a diameter? Well, if we go back to our equation here, x squared plus y squared equals 100, we know that 100 is equal to r squared. So our radius is 10, which means our diameter is going to be 2r is going to be 20. So if this line AB is a diameter of a circle, it's going to have a length of 20. Let's find the length of AB. So let's say length of AB. To do this, we're going to use our length formula that we've been working with. X2 minus x1 squared plus y2 minus y1 squared. And we just have to label our points here, x1, y1, x2, y2, and sub them in and find the length. So x2 is going to be 6 minus 8 squared, and then y2 is negative 8. We're going to subtract 6, and we're going to square it. So this is going to be negative 2 squared plus negative 14 squared. Okay, and of course taking the square root of all of this, this is 200, square root of 200, or approximately 14.1. Now, that 14.1 is less than 20, which is what we would expect if this is a chord. I mean, a chord, the longest line we can draw between 2 points on our circle is the diameter going straight through. So that would be 20. So length is less than 20. We can say that AB is a chord. All right. A second question here, working with the same situation, find the midpoint M of the line AB. Show that the line from M to the center of the circle is perpendicular to AB. So we've got 2 steps here. First step is we have to find the midpoint. Find point M. So to do that, we're going to use our midpoint formula. X is x1 plus x2 divided by 2. And y is going to be y1 plus y2 divided by 2. So we just want to sub in our x values and our y values from our points A and B. So our midpoint here, we're going to do 8 plus 6 divided by 2, which is going to be 14 divided by 2, which is 7. And then for our y's, we're going to have, let's see, y1 plus y2 is going to be 6 plus negative 8 divided by 2, negative 2 divided by 2, which is negative 1. So this point M is the point 7, negative 1. So we want to show that this midpoint is perpendicular, that the line from the midpoint to the center of the circle is perpendicular to AB. So sometimes it helps to just draw a little circle about a little picture of what's going on. So here's our circle. I'm going to put point A, point B. We know that they're a chord, so they connect 2 points like this. Our midpoint is right here. It's the midpoint of the line. The line that we want to work with now is the point from the center of the circle, we'll call that point O, to M, right? And we want to show that these 2 things are perpendicular. So to show that 2 things are perpendicular, we need to show that their slopes are negative reciprocals. So we want to show that slopes are negative reciprocals. So we need to find the slope of each line. So let's first find the slope of line AB. To do this, we're going to use our slope formula, y2 minus y1, x2 minus x1. And we can just sub in our values from points A and B. We can have negative 8 minus 6, 6 minus 8 gets us negative 14 divided by 2, divided by negative 2, sorry. So our slope is going to be 7. For this point, what's our second point here? Oh, we want the slope from from O to M. Slope of OM. Okay. This point O here is at the origin. It's the center of our circle, which is at 0, 0. Okay, for this equation, because our equation is just x squared plus y squared equals r squared. So our slope is going to be y2 minus y1. So we need the y value from our midpoint, which is negative 1, minus 0. Then we need the x from our midpoint, minus 0. Our slope here is going to be negative 1 over 7. So our slopes are negative 1 over 7 and 7 over 1. These are definitely negative reciprocals. Because we have like flipped the fractions and changed the sign from positive to negative. So therefore, these two things that we needed to show that they were perpendicular. So therefore, AB is perpendicular to OM. Right? So in this problem, we use the length formula, we use the midpoint formula, we use the slope formula, okay, to show some things were true about these lines. Right. Let's try another one here. Point P, 3, 5, is on the circle x squared plus y squared equals 34. Show that the line segment from P to Q is tangent to the circle. Okay, so ordinarily we would have to show that this point is on the circle, but we don't have to because they tell us that it's on the circle. What does it mean for a line segment to be tangent to the circle? Well, we need to show that the line PQ is perpendicular to a line from the center of the circle, so point O, to P. So again, if we make a little diagram here, O is the center of our circle, P is some point up here, Q is some point way up here like this. If this line here from P to Q is tangent to the circle, then OP should be perpendicular to PQ. Let's find out if that is the case. So to do this, we are going to have to calculate the slope of that line OP. So y2 minus y1, x2 minus x1. The center of our circle here is, because our equation is just x squared plus y squared equals 34, our equation is going to have a center at 0, 0. So we are going to choose, let's actually label the rest of our diagram here. P is 3, 5. So we can choose point P as our y2 and our x2. So y2 is going to be 5, x2 is going to be 3, and then y1 and x1 are going to be 0 at the center of our circle. So the line from the center to point P is going to have a slope of 5/3. Now we want to find the slope of that line PQ. Again, y2 minus y1, x2 minus x1. Okay. What are our 2 points here? There, P and Q. So we will choose point Q as our endpoint. So our y2 will be 11, our x2 will be 7, our y1 is going to be 5, and our x1 is going to be 3 from point P. We can do the subtraction here, 6 over negative 10, which if we put this in lowest terms is 3 over negative 5. So our two slopes are definitely negative reciprocals. So PQ is a tangent. Therefore, PQ is tangent to the circle. We'll do one last question here, one that's a little bit more challenging. Show that the line segment joining C and D, so C is at 5, 7, and D is at negative 3, negative 3, is a diameter of the circle x minus 1 squared plus y minus 2 squared equals 41. Okay, there are two ways we can do this. We could do it the same way we did the first question by finding the by showing that C and D are on the circle, and then finding the length of that line segment CD and showing that it is the diameter. We use a slightly different method in this one here. So first, we're definitely going to have to show that C and D are on the circle. Now, so let's draw this. If in fact C and D are a diameter, this would be the center of our circle, and this would be point C and D like this. Okay. If in fact CD is a diameter, notice that halfway, like the midpoint of this line CD, is the center of the circle. So we can show that CD is a diameter by showing the midpoint of CD is the center of the circle. So we'll do this in two stages here. Let's do the first stage. Number one, we'll show that C and D are on the circle. So to show that these are on the circle, we just have to sub those values in to make sure that our left side equals our right side. So let's do this for point C first. We are going to get on our left side, we are going to get, let's see, our x value is 5. So we'll do 5 minus 1 squared plus our y value is 7. 7 minus 2 squared. This gets us 4 squared plus 5 squared, 16 plus 25, which is 41, which is exactly what our left side is. Sorry, our right side is 41. So point C is definitely on our circle. Let's do the same thing for point D. Our left side is going to be, let's see, we're subbing the negative 3 here, so negative 3 minus 1 squared plus, a negative 3 here, so negative 3 minus 2 squared, and of course our right side is 41. So this will be negative 3 minus 1 is negative 4 squared, negative 5 squared, 16 plus 25 is 41. Okay, so 41, 41. We have shown that both C and D are on our circle. So step 2, show that the midpoint of CD is the center of our circle. Okay, first off, what is the center of the circle? Well, if we go back up to our equation here, we can see that the center of our circle is not going to be at 0, 0, because we've got like the brackets here, x minus 1 squared and the y minus 2 squared. But we do know that these values in here, h and k, that we're subtracting from y, are going to be the coordinates of the center of our circle. So the center of our circle is going to be 1, 2. Okay. So we can add that to our diagram. This is 1, 2 here in the middle. All right, let's find the midpoint of this line CD. So midpoint of CD. We can do our x, which means we are going to add our two x's together and then divide by 2. And we can do our y for our midpoint, which is going to involve adding our two y values together and then dividing by 2. So our C and our D, we have our coordinates there, 5, 7, and negative 3, 3. So 5 plus negative 3 divided by 2 is going to be 2 over 2, which is 1. And for our y values, we're going to have 7 plus negative 3 divided by 2, which is 7 minus 3 is 4, divided by 2, which is 2. So our midpoint is the point 1, 2. That midpoint certainly seems to be the same as the center of our circle. So since the center of the circle and the midpoint are the same, we can say that CD is a diameter.